Welcome to part 2 of an introduction to functions. In this video we'll take a look at graphing a function and also how to identify the domain and the range of a function. The good news is that graphing a function is just like graphing any other equation that we've done in the past. Meaning if we have the function f of x is equal to 4x minus 2, if we want to we could rewrite this as y equals 4x minus 2. Remember, f of x is equal to y. So if we want to graph this function, we have a variety of options. This is in sloped-intercept form, or we can go back to making a t-table. Just for illustration, let's go ahead and make a t-table. Remember, we can pick any x value that we want. Let's go ahead and select 0, 1, 2, and then maybe negative 1. So now we're just going to replace x with these values in this equation to determine y. So 4 times 0 minus 2, that would be negative 2. 4 times 1 minus 2 would be 2. And when x is 2, we'd have 4 times 2, that'd be 8, minus 2, that'd be 6. And then when x is equal to negative 1, we have negative 4 minus 2, that would be negative 6. Let's go ahead and plot these points. We have 0, negative 2, 1, 2, 2, 6, and negative 1, negative 6. So for the most part, graphing this function should be review, because we've been graphing lines now for quite some time. However, I do want to make the connection that if we have the point 0, negative 2, if we want to rewrite this using function notation, we would say that f of 0 equals negative 2. 0 is the input, or the x value, and the entire function value, or y, is equal to negative 2. For the point 1, 2, that implies that f of 1 equals positive 2. So we say f of 1 equals 2, which means when the input x is equal to 1, the output, or the y value, is equal to 2. And for the point 2, 6, we would say that f of 2 equals 6, meaning when the input is 2, the output is 6. Okay, and this problem also asks us to determine the domain and the range. Remember, the domain is a set of all possible inputs, or x values. And we know we can select any real number for the value of x, so the domain would be all real numbers. But let's take a look at it graphically. X values are the values that move from left to right. So as we can see, this line is slanted, but it does move left and right forever, verifying that our domain is all reals. Now the range is the set of possible outputs, or y values, and graphically this is the y-axis, so y values move up and down. And we can see graphically that this line does go down forever and also goes up forever, another indication that the range is also all reals. Let's take a look at another one. Here we have f of x equals x squared. And again, when we first start to work with functions, it may be helpful to rewrite this as y equals x squared. So let's go ahead and make a t-table. And let's select negative 2, negative 1, 0, 1, 2. Well, once we have our x value, to find y, we have to square x. So negative 2 squared would be 4, negative 1 squared would be 1, 0 squared would be 0, 1 squared is 1, and 2 squared is 4. Let's go ahead and plot these points and see what kind of graph we have. So negative 2, 4 is here, negative 1, 1 is here, 0, 0, 1, 1, and 2, 4. Here we have a U-shaped graph, which is called a parabola. And let's see if we can determine the domain and the range of this function. Well, again, the domain is the set of inputs, or x values. We can pick any real number and square it. So again, the domain would be all reals. Graphically, even though it's pretty clear this graph moves up forever, it is also slowly creeping left and creeping right, which does verify that our domain is all reals. However, if we look at our range, since we're squaring x, even when x is negative, y is always positive, or 0. So y is always going to be greater than or equal to 0. and that is going to be our range. Graphically, we can see that here's the y-axis, and the lowest point on the graph is right here when y is equal to 0. All the other y values are positive, verifying that our range would be y greater than or equal to 0. Whenever we're graphing a function, we can't always verify it in the graphing calculator because remember, f of x is equal to y. So when we have function notation, the equation is already solved for y. Let's go ahead and verify this one on the graphing calculator. So we'll press y equals. We're just going to type in the right side for y1. We'll type in x squared. So here's x. Here's the squared key. We'll go ahead and press graph. There's the graph of our parabola that we have here in red. If we want to find specific points to verify our t-table, we can press second graph, and we can verify that we have completed our t-table correctly from this screen here. Let's go and take a look at one more. Here we have f of x equals the absolute value of x minus 3. And again, if we want, we can rewrite this as y equals the absolute value of x minus 3. Let's go ahead and complete a t-table for this. Let's go ahead and use -2, -1, 0, 1, 2. Okay, so when x is -2, the absolute value of -2 would be +2 minus 3, that's -1. The absolute value of -1 would be 1 minus 3, that's -2. The absolute value of 0 would be 0 minus 3, that's -3. The absolute value of 1 is still 1 minus 3, -2. And the absolute value of 2 would be 2 minus 3, which is -1. Let's go ahead and plot these points. We have -2, -1, -1, -2, 0, -3, 1, -2, and 2, -1. So depending on your experience graphing absolute value equations, this produces a V-shaped graph, as we see here. Let's see if we can figure out what the domain and range would be. Again, remember the domain is the set of all x values for this function. And again, we can select any real number for the value of x. So the domain would be all reals. Graphically, remember the x-axis is the horizontal axis moving left and right, and this function does move right forever and left forever, indicating the domain is all reals. Now the range is a set of all y values. Remember the y-axis is the vertical axis. We want to ask ourselves, how does this function behave moving up and down? Well, it does go up forever, but it doesn't go down forever. In fact, the lowest y value is -3. So our range is going to be y greater than or equal to -3. Let's go ahead and show how to graph this on the calculator as well. Let's go back to y equals. Let's clear this out. To access the absolute value feature, we press Math, right arrow once to number, and then ABS stands for absolute value. So we'll press Enter. It brings us back to this screen. We press X, a closed parenthesis, and then -3. Graph. This verifies our graph, and then to find points on the graph, we can press second graph for the t-table. Before we finish, let's go ahead and go back to these ordered pairs and represent them using function notation. When x is -2, y equals -1. So using function notation, we would say f of -2 equals -1. When the input into the function is -2, the output is -1. The input is x and the output is y. So for the point -1, -2, we have f of -1. There's our input, and then the output will be the y value, or -2. Here we'd have f of 0 equals -3. Here we'd have f of 1 equals -2, and so on. Okay, that's going to do it for part 2. There is another video on the domain and range of functions. I do realize that when we first introduce domain and range, it can be a little bit challenging. I hope you found this video helpful.